What is going on, guys? My name is Hussein, and Cloudflare drops another cool engineering bomb on us. Unimog. Is that how you pronounce it? Unimog? Unimog? I'm gonna pronounce it Unimog. It's a layer 4 load balancer. Guys, I am self-aware. I know my limitation. I know what I know. I know what I don't know. And I don't know a lot of stuff. But load balancing and layer 4 proxying, I've been studying this stuff for over 3 years now. Been making videos on different technologies. Layer 4 proxying. I explored Nginx, how they do their layer 4 proxy. I explored HA proxy. They have different methods. Envoy, traffic, Caddy, and many other load. We know what layer 4 load balancing is. Cloudflare, when they came up with this, okay, they are making a layer 4 load balancer, okay. They took this concept and they raise it to the power of infinity. Layer 4, they basically reinvented what layer 4 load balancing really is. And I'm blown away by this thing that is called Unimog. I am literally blown away. Just in case you don't understand me talking in American English, I'm going to talk British. This is absolutely awesome. I don't think British say awesome. They do. They don't. Yeah. But yeah, I'm blown away. And I'm not gonna do this article or this blog it's justice by making a video, to be honest. I can spend 2 to 3 hours discussing this thing. And after reading this around maybe three times now, there are still things that I don't clearly understand. There are things that I grabbed and I understood by reading the article, and things that I never heard about before, things like especially low-level network concepts. There are things that are just like, whoa, it just blows me away. It's like, wow, okay, I never thought to do this at all, right? And I'm going to go through these pieces by pieces, talk through the different pieces of the article one by one, guys, and try to do it as justice, but I know I will not. So I'm going to reference it below. Go check it out. Go read it. This thing, I don't think it's available for us to test. It's their own thing, right? It's built for their cloud edge server. But I encourage you to read the article. So, and I bet that it took them months, if not more than that, to write this article. It's so detailed, it's so in-depth, and I absolutely love it. So how about we jump into it, guys, and discuss this. So, what is layer 4 load balancing? Guys, we know a load balancer is a reverse proxy. That's what we always know, right? It's a subset of a reverse proxy that accepts connections and then basically forward request to a backend server by inspecting the content optionally. And now this inspection of the content can occur. All of a sudden I'm Cardi B. Okay, so it can occur on a layer 7 or at layer 4. What does that mean? It means if you terminate TLS and you decrypt the content, you can look at HTTP traffic, you can look at WebSocket traffic, you can look at gRPC traffic, application layer traffic, and make decisions based on that. Example, hey, if you're going to /admin, sorry, we're not allowing you to do that. Block. Or you're going to /app1, go to this set of server because this is a specialized servers to serve app1. Or if you're going to /app2, go to this set of servers because these are beefy server, decide for long running processes and go there, right? So that's a layer 7 load balancer or reverse proxy. Layer 4, you're only allowed to look at the packet from layer 3 and layer 4, which is the IP and the port. So you can look at the destination IP address, which is plain text, the destination port, the source IP address, and the source port, and that's it. You cannot look at anything else, and you make all your decisions based on that. That's what layer 4 load balancer is. So it's very useful for stateful load. It's very useful for sticky sessions, right? Because WebSockets, very awesome for layer 4 load balancer, because I just want you to establish a connection to your backend and just forward the packet all the way to the backend server. Okay, very, very critical if you don't want to do application level inspection, right? It's faster because we don't need to decrypt the traffic. It's safer because you don't really need to look at the content, right? So you don't need to terminate TLS. So you don't need the private key of the server or the public key or the certificate, right? A lot of people don't move to reverse proxies because of that, right? And it's more secure as a result, right? Because, yeah, it's more efficient. I talked about layer 4 versus layer 7 proxying. Check out this video here if you want to know more about this. But here are the concepts of Unimog that's just completely different. The things I never thought about they're doing. Okay, the essence of it is still accurate. They're looking at the port and the IP addresses. That's it. They don't look at the content, which is great. But they're doing way, way, way more by just those two pieces of content. All right. The first thing that I just never heard of, to be honest, just basically because I'm basically not an expert in networking. I'm not a network engineer. This thing is called Anycast. Anycast, apparently, for the longest time, I thought, hey, IP addresses should be unique. All of a sudden, Cloudflare said, nope, we can have two data centers with the same IP address exactly. I was like, what? How can two things have the same IP address? Apparently you can if you own the damn thing. If you own the whole network, you own Amsterdam, you own London, Moscow, network, New York, San Jose, Los Angeles, you can craft your network such that all of them will have the IP addresses, and with the magic of the internet and the shortest route and the routing technology, if you are next to Amsterdam, your packet will be routed, and you don't want to get to this IP address, which is 104.17.175.85, which is the same IP address to all of these locations. If you're in Amsterdam, your packet will be routed to Amsterdam. Why? The power of the internet. Your packet goes from your phone to your ISP in Amsterdam, and Amsterdam basically forwarded to the next route and the next route until it goes to the nearest subnet, and that happens to be Cloudflare's Amsterdam IP address. If you're in London going to the same IP address, it will go to London's 104.17.175.85, right? This is called Anycast. How it works? I have absolutely no idea. It's all networking magics. If you're a network engineer, please let me know, because I couldn't find enough technical details. Obviously, this article doesn't discuss it, and it shouldn't, to be honest, because it's a networking concept. I started reading about it because I'm just blown away. I don't know how this works. How do you have two IP addresses without getting IP conflict? That's, for the longest time, when I used to configure computers with my dad back in 1998, so he would assemble them and I would do the software, I know that no two machines can have the same IP address. What is going on here? So this is defying the rules of logic to me. But apparently there is a way to do it, and it's called Anycast. So that's the first trick. By just doing Anycast, guys, you have free load balancer at the internet level, because if you're in Moscow, we will route you to the closest location. automatically, because all of you suckers are going to the same IP address anyway, which is awesome, right? All of them, or the app, if you have an app or you're going to a certain location, all of them will have the same IP address. So if you're in Los Angeles, you're going to go to the same IP address, and magically you'll go to Los Angeles because that's the closest, right? Which is really powerful. So that's automatically, we get that. Automatically, DDoS, distributed denial of service, is dead almost, because if you attempt to do a DDoS, what is a DDoS? Distributed denial of service. It is basically a coordinated attack from different location, and that's what makes it effective, because it's distributed. This kills it, because guess what? If you're from Amsterdam and network in New York, and I keep saying network, I don't know why I read it network, and San Jose and Los Angeles, and all these people coming from different locations trying to coordinate an attack, they're not going to a central choke point. They are distributed. Some of the attack will go to Amsterdam, some of the attack will go to New York, some of the attack, so they are thinner, right? And when you it's like the tale that the story that they told us when we were young. Like you grab one stick and you try to break it easier, and if you group like 10 sticks together and you try to break it, it's impossible to break. It's the same thing, right? This is it. So DDoS is for free, almost. Still, they have other DDoS mechanism, but this is just so awesome. That's the first thing that blew me away. I love it, right? And look at this. Internet is just one IP address. So that's really, really powerful, guys. So we talked about that. So here's the other thing here. I'm gonna talk about this is when they started implementing. They had a lot of peak load, right? When they implemented it, everything goes smoothly, right? Implemented Unimog, and we're gonna talk about Unimog. Here they talk about the difference between, which I explained, the layer 4 versus layer 7, proxying here a little bit. And then another concept which I talked about called virtual IP addresses. This is very critical here, okay? And the concept of virtual IP addresses, guys, I talked about it here. Go check that video. Essentially is assigning the same IP address to a cluster of servers, but every machine will have their own direct IP addresses. So when I say DIP, they use the same terminology here, versus VIP, that's what I mean, right? So all this cluster of machines have, all the cluster of machines have a single VIP, virtual IP address, but each one of them have a direct IP. So if you send a message, a packet to the virtual IP address, it will essentially be load balanced at the router level. The router will take it to this, or take it to this, or take it to this, and there is another layer that will forward the packet to the direct server, right? Because the final destination is not just the VIP, it's actually the actual IP address of that. Okay, here they talk about TCP, which we talked about many times in this channel. Go check the TCP, three-way handshake, and all that stuff. We talked about that you only have source address, destination address, source port, destination port. That's the only thing you can look at layer 4. Forwarding packet. This is what I want to talk about. This is the meat and potato of Unimog. Unimog, is that what it's called? Unimog. Unimog. I'm sure someone will gonna say, no, that's not the correct way of saying it. So let me know, guys. All right, forwarding packets. How do we forward packets? So, and here's another thing that I didn't know, which I'm going to talk about a little bit here. Forwarding packets. This is the most interesting part of Unimog. So they go through different diagrams and showing different concepts here. So the first diagram here is showing without the concept of layer 4 load balancing, using just pure router technology, which is called the ECMP, or equal cost multipath. This is another thing I didn't know about. And it is a networking trick to actually balance the bandwidth between two paths. So let's say that's the origin. It was designed. So let's say you have point A and point B, but there are multiple paths to go to this point, right? ECMP, which is the equal cost multipath, will basically forward the packet to different path instead of sticking to one path, so that the bandwidth is shared between the servers. However, you can use the same technology to treat the router as a load balancer by using the same thing. Have this, all the servers have the same IP address, which is this virtual IP address concept, and each one of the server will have its unique IP address essentially, right? But if you have all the same IP address, the router will try to pick different routes every time. But technically, it will also, the packet will end up on a different router or a different server with every single request, right? That's basically based on certain hashing algorithm, right? So that it always, the packet, if it's from the same source to the same destination, always goes to the same server, because we want the stickiness always when it comes to layer 4 proxying. So that's without any technology, just using this router, and just you can load balance. However, ECMP has some limitation. They talk about these details. Again, go and read that. Okay. The limitation is, what if one of the server goes down, or one of the link doesn't cost as much as the other link? Then you start distributing the packet, and immediately the connections will break. Immediately, because if you don't forward the request to the correct server, the server will say, "What the heck is this packet? I'm gonna reset the connection. This is not for me." And you can essentially break the connections as a result between the client and the server. TCP reset, we talked about that, right? So what they decided says, okay, and it's to avoid this problem, let's put a specific, almost static load balancers on top here. And then do the ACMP to the load balancers. And then the load balancer connect to the server, right? Because that's what we know. That's exactly what we have been doing for the past 3 years in this channel. Doing load balancing, actual software load balancers. That's HA proxy, that's Nginx, that's Envoy, right? That's traffic, that's Caddy. And then that will load balance to the back. You know what they did? It says, nope, we're gonna change the whole thing. And here's the genius behind this. They made the server into a load balancer. So Unimog, hopefully I keep pronouncing it right, is installed on every server. And guess what? We're going to come to that. It is actually installed as part of the kernel itself. I don't know which operating system exactly, but I'm pretty sure it's Linux. They made a change to the kernel so that this server is installed with a specific flavor of an operating system which has a specific kernel change. That is the load balancer. So you get a load balancer whether you like it or not, son. You spin up a server, that server is a load balancer. And it's your application as well. Mind blown. Okay, Hussein, how do this... Now, that defeats the purpose of a load balancer, right? Because load balancer is a single entity that is a stateful in its knowledge of which servers it's consumed, right? Because it knows, oh, I'm connected to this server, I'm connected to this server. But if you now have like 100 load balancers, which are also servers, how do those communicate with each other? They do, actually. They communicate with each other, and they need something called the control plane. They have a control plane. I'm going to explain it in a minute here. They communicate with each other using the control plane. They have a control plane which has a forwarding table which tells these servers what to do, which tells these servers, oh, server 7 is dead, server 3 is awesome, server 2 is meh, server 1 is almost dead, server 8 is about to handle new load, oh, server 10 just came into the party, we can send him some traffic. It does all of that stuff, and that's called a forwarding table. So, mind blown. So let's walk through a scenario, guys. Here, And they're using this concept of XDP, which is what's called the Express Data Path, and I'm gonna explain that in a minute. So much stuff to explain. Oh my god! And I know, guys, I'm not doing it's justice. This is a genius technology, and no matter how I'm gonna talk about it, I'm gonna miss something. I'm pretty sure I'm gonna miss something. So your request comes from the internet, goes to a virtual IP address, obviously, right? You don't know anything about the backend servers. So you go to a specific virtual IP address. It goes to the router. The router does its ECMP and forward the traffic to one of the servers. Just not randomly, but based on its own algorithm. But that's not enough. That's not a load balance that we want. The server here now receives the packet at the kernel level. Let's go to another. Before we go to the other, let's explain this here. Receives the packet at the kernel level, and it says, okay, you're going to this virtual IP address. But guess what? This virtual IP address doesn't exist because it's a virtual IP address. It's one of us, 700 servers. Which one? Well, it's based on the load balancing algorithm, and I'm gonna hash your source client IP address, your destination IP address, your port, all of that stuff. It does a specific algorithm. I don't think they discussed the specifics of the algorithm. I might be wrong there. But based on the hash, okay, server 7. I'm now need to change the packet IP from the destination being the virtual IP address, which doesn't mean anything, to the direct IP address. However, you can't do that. Why? If you change that packet, we lost the information of the destination, which is the virtual IP address. We cannot just change it. So they do something called encapsulation, and they talk about it right here, somewhere here, encapsulation here. So they encapsulate the packet with the direct IP address of server, whatever we said, server 7, it becomes the real destination, but the actual virtual IP address remain intact. So they encapsulate it with another TCP packet, and then they send it to the actual server, and that's these arrows that you see between the servers. I apologize for the podcast people listening, but essentially what happened here in the show notes, you're gonna see it is two servers communicate with each other. The internal cluster of servers everyone communicate with each other. So despite me receiving that packet as server 1 from the router, I'm not the final destination technically. Server 7 is. So I'm going to send the packet encapsulated to server 7. And the server 7 will actually process that based on the forwarding table, right? I did that because of the forwarding table. It told me to do that. And then once I do that, I process the packet and I respond. How do I respond? Whom should I respond to? Guess what? You should respond to, not to server 1, which is the one who actually sent you the packet, but respond to the actual virtual IP address. Where the heck is this virtual IP address? Well, it was encapsulated, so use that as your source IP address and send it across the internet again. And that's how it works. That's how it works, basically. And now I'm going to talk about XDP, which is the Express Data Path. This is essentially so critical. Let's go to the diagram. This is the diagram. This is the beautiful diagram. Again, I'm going to put it in the show note. So a packet received at the server level, which is that thing that we talked about. It's a network card, network interface, which is Wi-Fi, Ethernet, whatever, right? And the packet goes into their custom module, which is called the XDP program. It's a kernel level program. And before we send it to the network stack, to the kernel network stack that does its parsing and does all that stuff, which is called Cloudflare in this case, they built this and they put it at the kernel level. Guys, it does not get any faster than this. You are at the freaking kernel. You're at that lower level. That's a layer 4 load balancer, guys. They take the packet and they have this beautiful module called layer 4 drop. Why? That's a DDoS for you. That's a denial of service level checker. So they drop the packet right there and then at the kernel level. It doesn't reach your application. It doesn't bother your memory. It doesn't bother your user space. It doesn't need to touch you. You're invincible, babe. You're invincible. It doesn't even touch you. L4 drop kills it right there. If they detect it, and how do they detect it? I don't know. Probably they have some metrics in the control plane that tells you, oh, this IP address is a little bit shady. It's been sending a lot of these SYN flood packets all over the place. How about we can just kill it? So L4 drop is awesome. And then L4 drop, if it actually passes that filter, it just passes it to the next module, which is the Unimog, which is the layer 4 load balancer, which does all this magic, right? So either if the server, if the Unimog checks, okay, is this packet destined for me? Yes, it is destined for me. Forward to the network stack, and that goes to the service and application, right? No, this is forwarded to actually to the virtual IP address. Do your router. Where's your routing table? Where's your forwarding table? Query the control plane, and that's the dashed line here. The control plane contains the routing table that goes through all that stuff. So we would query the control plane and says, okay, where the heck should I forward this packet? Oh, you should go to this. So it will do the transmit. So it does three things, these express data plane. Either drop, pass the packet, or transmit it back to the network interface, which either goes to another server or goes to the same server based on the algorithm. This is just so freaking good. Encapsulation, we talked about that. That's the encapsulation packet. We talked about that. Forwarding logic, we talked about that. That's the forwarding table. We talked about that as well. Maintaining established connection. This is just nuts, man. There's another thing I didn't understand. So first of all, guys, the whole thing is stateful. Layer 4, right? It says stateful. The table is stateful, right? So if I'm gonna send a packet, it must and always go to the same server, the direct final destination server. Any future packets must always go to the same packet, right? Because this is a layer 4 load balancer. We cannot afford to go to another server because we're gonna get reset. We're gonna get disconnected. However, if any of these forwarding table breaks for any reason, and that's what I understand, why would that break? I did not find an answer for that. Why would a forwarding table says, okay, and instead of going to A, go to B? Why would that happen? I couldn't find an answer for that. But let's say it happens, okay? If that happens, all of a sudden, B's traffic is now A, and if you have a connection with B, and all of a sudden you go to A, A will respond back with a reset, right? So the XDP actually protects against that by adding another column saying, okay, this is the second hop. Don't immediately reset the connection. Try to see where this original connection was coming from, right? So they try to solve it by adding another hop, essentially. Okay, that's what I understand from that. So it will redirect again to the other server. So adds a little bit of a cost. To me, I don't understand why we need that, to be honest. Okay? Why don't we just always hash, and by hashing the content, we guarantee that the destination always goes to the same server. But here's the thing. If you're establishing a multiple connection from the same IP address, then this could be problematic because this will, if you're using a dumb hashing algorithm, this will always give you to the same server, which is something you don't want. You want to load balance that. Apparently, they're using something I don't understand. So they're apparently adding another some flavor message. I guess that is the source port. The source port changes. It's never the same port. Yeah, I don't understand that. I would never allow it to go to that state, to be honest. I'm definitely missing something, obviously. To me, I would basically hash everything and I guarantee that always go to the same server. And that server is dead. That server is dead, right? Because, yeah, tough luck, client. Go reset your connection and reconnect again. And if you try to reconnect again, that's the problem. If that server is dead, then okay. I think I understand now a little bit. It's more complex than it thinks, right? If the servers go down and go up, the algorithm will definitely change, because you cannot always hash it to the same server. What if this server is dead, right? That's actually very interesting. Man, this is so cool. Control plane. This is one of the most important. They admit it. They say this part of the process is the most difficult to maintain. And they use so much technologies, right? I heard a lot about HashiCorp console, but I never actually used it. Guys, if anyone use HashiCorp, let me know. They use the console key value store apparently to store the forwarding table. They have health. Obviously, they store. Here's the information they store in the control plane. They store server information. Unimog, I'm pretty sure I'm pronouncing that wrong, needs to know the set of servers present in the data center, obviously, right? The list of their DIP addresses, all that stuff, which services, what they do, their health, whether they are healthy or not, their load, how much are they loaded, CPU usage, all that stuff, utilization, IP address information, and other stuff as well. And here it is, the Cloudflare Edge Center router. And call it Edge because it's on the edge, right? Before the backend server. Edge computing is the next thing, guys. Like, I mean, I want to talk about the backend, but Edge is technically a backend to the front end, but it's a front end to the backend. Does that make sense? Still, the backend technology is still there, but its edge computing is its own field now. It's a legit field with proxying. I guess I talk about proxying a lot, and a lot of people slot proxying and load balancing as edge computing. Not all of them, though. Prometheus is another thing I need to talk about. A lot of other stuff. It is a critical system. It is a critical system. Unimog is a very critical system. And they also support UDP. UDP is very interesting because it's a stateless protocol, technically, right? And however, you need it to be stateful when it comes to Quick, right? Because Quick is a stateful protocol built on top of a stateless protocol, which is UDP. So I pretty much think that Quick solved this problem. But what happens if my UDP packet goes to another server? I think you have to build application level routing that forward all your packet to the same server. Otherwise, it's going to be very interesting. And unless there is the connection upgrade that allows you to reset a connection based on that, right? I don't know much about Quick. I didn't research it enough to know what happened in that case. But yeah, this is a badass proxy, guys. I'm pretty sure I missed a lot of stuff. But the genius here is, to summarize, the genius here is pushing Unimog. I'm pretty sure I'm pronouncing it wrong. Unimog to the kernel and having a control plane to have a state where the router table is the genius here. For the longest time, load balancers are stateful in a sense that they store a state in memory about the information at the backend servers, right? They move the state to the control plane, and the load balancers at each server are now stateless, and they get the latest state from the control plane. I think they push this information to the control plane. How? No idea. I know nothing about Linux kernel. Literally nothing. Yeah, I need to educate myself a little bit about that. But the communication between the control plane and the Linux kernel is a little bit complicated because I don't know. How would you communicate? Sockets? Probably not. Processes? Maybe. I don't know. File descriptors? God knows. Guys, gotta say, I'm blown away. I am blown away by Unimog. And I'm not sure if this is available for us measly engineers to use. They didn't mention any there. Is this open source? No, there it's not. Although the XDP programs are written in C, XDP itself is written in Go. That's the control plane, right? Go, much of it is code specific to Cloudflare, but in the course of developing it, we have collaborated with Cilium to develop eBPF, an open source Go library that provides the version. What? Interesting. So they are bringing it. Guys, we know this stuff, right? Every technology that is get developed, speedy, get developed in Google, and then it turns into HTTP2 for the public, right? Kubernetes, what was it called? Kubernetes used to be called Storm, not Storm. I forgot what it's called. What was Kubernetes used to be called? It started with an S. I forgot. So it was Boris. God damn it. Okay, I need to Google this. Borg. Did I say Boris? Boris reporting. Only the Red Alert fan will know this. Boris reporting. All right, so yeah, Borg. It was to be called, and it was so sticky with Google infrastructure, so they rewrote it to be Kubernetes for open source. This is the same thing. It was obviously when you develop such thing, it's going to be sticky to your Cloudflare infrastructure. So they are open sourcing it to be a Go library. I don't know why Go. Do you really need that garbage collection poses at that level? That should be written in C, in my opinion. I don't know. I don't know much about Go. I know it's a good language, but I mean, at that level of the kernel, I wouldn't want something that has a garbage collector. I would go with Rust or C++. But I don't know. What do I know? It's just an interesting choice, let's say. All right, guys, that's it for me today. What do you think? What do you personally think about this? If this came to us, it's obviously, I think it's an overkill for most of us to deploy. We're not Cloudflare big. I think this is the same mistake, right? We see an exciting technology like this and we jump into it right immediately, right? We should hold our horses a little bit when it comes to this, right? With Kubernetes, it worked for Google because Google is Google, for crying out loud. But a lot of people make the mistake of just implementing Kubernetes from day one, and they don't even need it. Pure good old VMs do the job. Sometimes you have to think simple. If you only solve a problem that you have, and that's what Google did, and that's what Cloudflare have. Cloudflare serving, I don't know how many percent of the internet. They're serving the whole internet, for God's sake. Of course, they need something special. Mike Tire Pro will not probably need it, or Janet Donut Shop will not need a Unimog layer 4 load balancer, probably, right? So we have to think like that. We have to be pragmatic a little bit and pick the technology that solves our problem. Don't pick the tool because it's just cool, right? Or sexy. I know this thing is sexy, Unimog. I don't know why this is an ugly. That's an ugly logo, guys, for this. Ugh, really? That's what you came up with? Such sexy technology, and you pick up a truck? Guys, Cloudflare, you gotta come up with a better icon or logo for Unimog. That's not badass. That is not doing it. It's justice. Guys, that is not. I like the Cloudflare logo, but that's not a Unimog, man. I imagine, I don't know, an eagle or a snake or something like that. Come up with something more badass. That's not badass. That logo does not do the justice for this badass software. This thing is badass. So I don't know. Pick up something that is looks really tough and doesn't die like a cockroach. No. Don't pick that. I don't know. Pick something else. Not a truck. Blue truck. Okay, no. And look at the truck. The stuff is about to fall from the truck. I don't know. Nah, I don't like it. I don't like the logo, guys. That's the only. I love everything about this article except the logo of the Unimog thing. All right, guys. Great job, guys. David Rag, thank you so much for writing this awesome article. I don't know what to say. I know I didn't do this justice. This is a long video, I know, but this is just big. This thing is really huge, and I really need to learn more about it. It's a very detailed article, definitely, but still, there is so much. I'm pretty sure there's so much that they just couldn't cover, because that's a deep level article. And I wish we have more of this stuff. We need more of this stuff. And Cloudflare are doing a good job detailing. They are doing these detailed blogs. I love everything of this. I love it a lot. Obviously, guys, Cloudflare is not sponsored or anything like that. I just love to talk about this technology. That's anything that I love, I just talk about honestly in this video. All right, guys, that's it for me today. I'm gonna see you in the next one. What do you think about this Unimog? Do you think it's good? Do you think it's over engineering for us lowly engineers, or is it just designed for highly scalable, big apps, essentially big networks, big companies, right? Let me know in the comment section below. I'm gonna see you in the next one. You guys stay awesome. Goodbye.